Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at using the elimination method to solve simultaneous equations. Now, we already looked at the substitution method, but that required that one of the equations had either x or y as the subject. What if we have a situation like this? We have two equations, but neither x nor y is the subject. It would be quite effortful to make x or y the subject in either of these equations, so we need another method, and that's the elimination method. Now, as the name suggests, the goal is to eliminate one of the variables, either x or y. Okay, so which one do we eliminate? Well, we eliminate the one that has the same number in front of it in both equations. So if I wanted to solve these two equations simultaneously, what I would do is I would get rid of the y's because the y has a 3 in front in both equations. Okay, so how do I eliminate the y's? Well, we follow this rule. You add if different sign, subtract if the same sign. What do I mean by that? Well, these two y's both have a 3 in front of them, but they have a different sign. One is a negative, one is a positive. When you have that situation, we add together the two equations. So we go 2x plus 5x is 7x. Now, negative 3y plus 3y is 0. That's why we're doing this, to get rid of the y's. We also have to add 4 and 31 together. So adding together these two equations gives 7x equals 35, so x equals 5. Now, we are not done. We found x, but we need to find y. To find y, we substitute this into either equation. Doesn't matter which one. So I'm just going to substitute this back into the top equation. So 2 times x minus 3 times y is equal to 4. Subtract 10 from both sides. Divide by negative 3, y equals 2. So the solution to this equation here is x equals 5, y equals 2. Again, we normally write it like this as a point. This is a line, this is a line. If you were to graph both of them, they would intersect at this point. So you might be asking yourself, well, what if we're not so lucky? What if we don't have a situation where the x's or y's have the same number in front in both equations? In that case, you have to multiply one or both equations, and I'll show you an example of that now. So let's solve these two equations simultaneously. Once again, each of these equations has infinitely many solutions, but there is one solution to the top equation that is also a solution to the bottom equation, and that's what we're trying to find. Now, neither x nor y is the subject of the equation, so we can't use substitution. Instead, we will use elimination. We want to eliminate either the x's or the y's. The problem here is neither x nor y has the same coefficient in both equations. So what we need to do is multiply one or both of the equations. What I want to do is multiply them in such a way that either x or y will end up having the same number in front. Sounds a bit complicated, but if I multiply this top equation by 3, that means I have to multiply everything by 3. I have to multiply 7x by 3, negative 2y by 3, and 59 by 3. Now, if I multiply this bottom equation by 2, I will be able to eliminate the y's. The reason is negative 2 times 3 is negative 6. Negative 3 times 2 is negative 6. See, I'm multiplying them in such a way that the y's will have the same coefficient. So I have to multiply everything in the second equation by 2. And now I have a situation where y has the same coefficient in both equations, and thus I can eliminate y. Now here, the y's have the same sign. Both have a negative. When that happens, when they have the same sign, you need to subtract one equation from the other. It doesn't matter whether you substitute the bottom from the top or the top from the bottom. Either way is fine. So we're going to do similarly to how we did the last example. We go 21x minus 8x is 13x. Now negative 6y subtract negative 6y is 0. It's negative 6, that becomes a plus 6, equals 0. That's why we did it, to eliminate the y's. We also have to do 177 subtract 112, which is 65. So we've got 13x equals 65, and that means x equals 5. We're not done, we need to find y. So substitute this into either equation. Which one you choose doesn't matter. So I will just choose the bottom equation. So we get 8 times x minus 6 times y equals 112. Subtract 40 from both sides, divide each side by -6, you get y equals -12. So the solution here is x equals 5, y equals -12. Once again, this is a line, this is a line. If you were to graph both of these lines, they would intersect at this point. All right, let's now look at a harder example. So far we've only looked at linear simultaneous equations, but you can use the concept of elimination in simultaneous equations like this that are non-linear. So here we have two variables, x and y. We want to eliminate one of them. We're not going to be able to eliminate x or y by adding the two equations, but here we can actually divide one equation by the other, because x divided by x is just 1. They cancel out. So I've eliminated x. Now y to the power of 5 divide y to the power of 2, keep the same base, subtract the indices. 288 divide 36 is 8. So I get y cubed equals 8, y equals 2. Again, I'm not done. I need to substitute this into either equation to find x. So I have x times y squared equals 36. Divide each side by 4, you get x equals 9. So these two here would not be lines if you were to graph them. However, we can still solve simultaneous equations even when the expressions are nonlinear. All right, let's now look at a worded problem. So here we have 400 students, half of all boys and a quarter of all girls were born overseas, 155 people born overseas. We're going to calculate how many boys and how many girls attend the school. So this is a question for which we use simultaneous equations because we need to find two quantities at the same time. We need to find how many boys attend the school and how many girls. So we start by defining our variables. Let x be one of the things you want to find and y the other thing you want to find. So after we've defined our variables, we need to form two equations. So the first equation is there are 400 students at the school, so number of boys plus number of girls equals 400. The second equation tells us that half of the boys plus a quarter of the girls amounts to 155 students. So to solve this and this equation simultaneously, we need to multiply one or both equations so that either x or y has the same coefficient in both equations. So what I can do is I can multiply this one here by 4. If I multiply this by 4, this will become a 1y, and I'll have the same coefficient in both equations. I could just as easily have multiplied by 2 to make x have the same coefficient in both equations. So multiplying this bottom equation by 4, a half by 4 is 2, so I get 2x plus a quarter by 4 is 1. 155 by 4 is 620. I'm leaving the top equation unchanged. Now I have a situation where I have y with the same coefficient in both equations, and y has the same sign. When you have the same sign, you subtract. I'm going to subtract the top equation from the bottom. I'm going to go 2x minus x. That just leaves x, and then I'm going to go y minus y is 0. So y is eliminated. I get 620 minus 400 is 220. So that means there are 220 boys at the school. Since 400 students attended all up, it means that there are 180 girls. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.